Hey everybody, Kit Merker here from Noble9, and I'm with Grant Miller. He's the CEO of Replicated, and he's going to show us three very cool Kubernetes-related open source projects today. Say hi, Grant.
Hey, thanks for having me, Kit.
Good to have you here. So we've got three projects on the docket today. Can you tell us what we're going to see?
The first project is something called Kots, right? So that's kind of the overarching, product and project that we talk about. Generally, it's Kots with a K, right? So it's a play off of the idea of commercial off-the-shelf software, COTS, and that's kind of another name for shrink wrap software, on-prem software from the days of old. Kubernetes provides these amazing sort of patterns and primitives of reliability, and so one of the main challenges with traditional on-prem software was just it was so unreliable. Like you'd have these IT admins that were forced to do follow the sun support in order to manage the ERP system, the CRM, and an Exchange server. With the advent of Kubernetes, you end up having this amazing substrate that actually knows how to operate all these applications. And so with vendors building so much of the operational knowledge into Kubernetes manifests, it just became very obvious that the future of software is for vendors to take these sort of Kubernetes-based applications, the images and the manifest, deliver those to enterprise customers and let them run completely private, completely separate instances of the application. So this way, instead of sending data out to thousands of different applications, we can start to send the applications to where the data already resides.
The next one also starts with a K for Kubernetes?
It does. You are correct, sir. The next one is called Kurl. But it's Kurl with a K. So this is your Kubernetes URL. Think about wanting to build your own distro and naming, what's the networking and the ingress and the storage options you want to provide. I kind of call it like an add-on manager because ultimately, Kubernetes has these various add-ons. And so how do you kind of couple those all together to create an installable version of your product? And the Kurl project, what it does is it defines how to couple those together. And then it actually runs a server that will generate a URL that we host for you at curl.sh. And then that can be installed into a cluster, or it actually creates this air gap package, and it gives you all the installable components and the install script to run on a VM. And so I can actually show you that one here. This is the Kurl website. And so basically, what you see on the left is the various add-ons that we support. There's a handful of others we can look at in a second here. So we kind of show you, hey, we support Calico and Contour and Minio and Prometheus, and so all these different add-ons. And you can select over here just what versions of these you might want to have. So let's say I want to do KH117 with this version of Weave, this version of Contour, and then maybe I want to add in Valero, so I'll add in Valero. Obviously we give you the option to add in our little Kots project, but you don't have to add it in. You can use it completely independently. And now I have a little installer, so it creates a unique URL. And if I run this, well, first, if I just look at this URL, it's going to show me what's actually in that installer. So it's going to show me each of those versions and kind of give me a little landing page for what's about to be installed, tell me how I can download the air gap bundle. And kind of, as I mentioned, it has a Valero, it has Prometheus, it has all these different components in it. And then if I take that URL and I run this online installer and I, create a little VM instance inside of GCP earlier, and I run this, it's actually going to start to install that instance of my Kubernetes distro. So, and you can, if I wanted to, I can actually get into some pretty advanced configuration options. There's override flags that I can put in as the end user. There are also ways for me to add in, advanced options. So maybe I want to change the, minimum protocol version, or for Weave, I can, disable encryption. Kubernetes, I can, advance this, identify the service-sider. There's lots of different components here, and this will all be embedded in that URL that you use for installing your version of Kubernetes.
Is it possible to create a version of this that's incompatible or everything's tested or what?
It is definitely possible to create a version that's incompatible. So there's a foot gun available if you need it. We were starting to do is specify what those compatibility issues might be. So when you look at our add-ons, we have this idea works well with, is incompatible with, so Calico and Weave, you can't install those in the same cluster. But this is an open source project that we'd love to get more, involvement in. We actually started working a little bit with the cluster add-on folks and to try to figure out if we could, work together. Ultimately, this is a product and project that we needed internally at Replicated, like for our customers, right? So like HashiCorp or for, Puppet's a customer of ours, Tripwire. When these folks are delivering their, on-prem version of their product to an enterprise, not every enterprise has a Kubernetes cluster that's ready to be installed into. And so sometimes they need to bring Kubernetes along with it. So Joe Beta calls this the idea of like embedded Kubernetes, right? That there's a version of Kubernetes that just is sort of designed to run with this application. And so we've always had like a Kubernetes installer that would set down, from a curl pipe bash script or from an air gap install package would set up Kubernetes. And so we said, well, why not just open source that? Like, we don't think that we don't believe we're not trying to extract any value from our Kubernetes installer. We just want Kubernetes to be there. And so why not make it really easy to bring an upstream Kubernetes with lots of great add-ons, and then make that an open source little project that we can collaborate on together.
So you have I think the third project open too, which is called Troubleshoot, if I'm not mistaken.
No. Just Troubleshoot. We didn't put a K in front of that one.
What's this thing do?
So Troubleshoot is really a combination of kubectl plugins. So there's two kubectl plugins. They're both actually in.
Oh, sorry. Are you referring to kubectl?
Yeah, exactly. No one has kubectl, is how I like to say it. So that's how I'm going to say it from now on. So these kube control plugins that we provide, and what they do is they extend kubectl so you can perform a pre-flight check or generate a support bundle. And you can see a little sort of demo of what's happening at the pre-flight checks here. There's a little CLI UI that comes up, and it's basically taking a specification, and it's actually like a Kubernetes like custom resource. It doesn't deploy into the cluster, but it uses your local kubectl permissions to like execute some commands against the cluster. But it's still like a valid Kubernetes resource. And you can describe like things that you might want to know about a cluster that you're going into. So if you're an application provider in a pre-flight check, you might want to know if this is, an EKS cluster, right? If to do that, like we have a little shorthand that'll get that information for you, and then it'll surface that information back to your customer. This is, not a supported distro. This is a supported distro. You can also take that out in the form of a support bundle, which will, if your customer's already running the application and you want to get a bunch of knowledge about like, okay, well, what's going on with this cluster? What are they running in here? You can build and concatenate a bunch of these different support bundle specs and analyzers together. And this will allow an application vendor who's delivering their sort of like Kubernetes application as an on-prem application to easily troubleshoot and collect all the different info. So sometimes if you're doing installs like this, there would be this back and forth between the support team of the vendor and the customer. And they'd be like, oh, can you run like, can you get the pods? Can you describe, the pods? Can you there's all these commands that they're asking people to run. And so instead, what we encourage our vendors to do, and really any Kubernetes software vendor, is to put all those commands together into one spec, deliver it to the customer, and then instead of requiring them to send the support bundle back, actually we build a little framework that we call analyzers, which will go through all the collected files, and it can look for output and combine different logs together and give you the ability to surface up error messages to your customer. So that way they know, okay, looks like you don't have any kind of ingress set up and we need that in order for this to run. Or it looks like, something from our application logged X, Y, and Z, and we can give you a solution to what you might be able to do next.
So if I'm an application developer, I work on Kubernetes, or I use Kubernetes to deliver my apps. You're saying that what I can do is create this support bundle concept, lets me kind of give them a client side, analysis or way of seeing if what they've deployed is compatible with my expectations, and then also help them give me better feedback for debugging. This is to help my support team, right? That's the idea?
Yeah, exactly. So Troubleshoot is really two parts, right? The first part is make sure that is pre-flight to make sure that the cluster that you're going to be installing into meets all of your application's requirements, right? So what does it do there? It runs a bunch of commands against Kubernetes, validates that it has the resources it needs, it has the storage or whatever else you might need, or has access to some a fast enough disk, whatever it is. We can kind of get pretty detailed into what we can check for, and then it gives your customer warning, error, or success, and tells them, okay, look, I should be able to install this app. It meets all the pre-flight checks.
It also could probably help with avoiding sending data outside of a controlled environment too, right? If the customer is not interested in sharing like just the raw logs with you, or they're dumping the raw export, they can get a little bit, do some of the analysis and send the summary back for support, right?
Exactly. So then when it comes to troubleshoot, right, that's where we're collecting the information from the IT admin at the enterprise, from their workstation. They're running this kubectl plugin. It's all open source. They're running this plugin against the spec that you provided. That's going into the cluster, looking at different information, maybe pulling out logs. But instead of like that information then being sent up to you as the vendor, it first is processed on their workstation, or there's a component of this that can run in the cluster and kind of do this more continuously. But it's looking for whatever spec that you provided around the analyzers. So, hey, look, there's this log message. Let's like surface up that you need to add more disk space, or there's this challenge for ingress. And so you can basically build a run book or a playbook of all the different support tasks that you would do in order to troubleshoot an instance. And instead of doing that as a manual sort of guide, you would just make it you kind of codify it as these little specs that we create, deliver it to your customer. And then to your point, they can be in a completely disconnected environment. They don't have to share that sensitive information with you. And Troubleshoot also has pretty advanced redaction built into it. So even if they do need to escalate it up and send it to you, they can redact all the information out.
It looks like your curl is done curling.
Oh, nice. I can kubectl into it. I can add nodes to it. If I run this, if I want to add worker nodes, I can. This is all based on kubeadm, so it's just like a kubeadm based installer with lots of different add-ons. And so this now has Prometheus running up on it, so I could go to Grafana if I want. Like if you're a vendor who's going to be embedding Kubernetes with your application, you want to be able to provide the Kubernetes that and works well with your app.
I could imagine that being useful for a internal IT admin too, right? If you were a cluster admin and you're trying to create different environments for your internal developers or staging environments, things like that, I could imagine that being useful to make sure that the Kubernetes versions used internally are not just random ones found on the internet, but actually somewhat controlled and constrained.
Yeah, sure. I mean, it's that's not the intended use case, right? We like designed it to embed with applications. And if you're an IT admin, like you can use Kurl and you can create an install URL and then hand that out to your team, and they can all install from it. And you can add in different add-ons and kind of create your own little custom distro that's super repeatable.
So we looked at Kurl and we saw Troubleshoot a little bit. You talked about Kots, but you didn't really show us anything. I see you got the Kots.io tab open. You want to show us a little bit of Kots?
Yeah, sure. I mean, so Kots, itself it's kind of these two parts. One is the CLI that you can use to install applications, but the other part is this admin console, which is what you would use as an IT admin to manage the life cycle of an application. So this gives you a little screenshot idea of what we're doing here, right? This component becomes the admin console for any of these Kubernetes off-the-shelf software applications. And what that means is you can collect configuration info here. You can collect a troubleshoot bundle. I mentioned these are integrated pretty well together. And then the one really cool thing that we love that we did with Kots is we integrated it with like a GitOps workflow. So if you think about a third-party application, even a Helm chart, right? There's sort of an upstream repo or an upstream vendor that you're getting it from, but their manifest often describe the registry that they host the images in, right? So Docker Hub or somewhere else, or ECR. And if you're an enterprise, you often, you don't want to pull images on your cluster from the public internet, but rather you want those images to be in your internal registry. And then sometimes, you actually don't want to just have this little admin UI deploying applications, but rather you operate by putting everything through version control. And so the cool thing that Kots does with our admin console is it integrates into an IT admin's internal version control system and their own internal registry. So they provide credentials for both. And then every time there's an update to the application, we will actually download all the latest manifests and the images. We'll retag and push the images into their internal registry. Then we'll take those new image locations and we'll overwrite the upstream manifest with those new image locations as customized patches, customized with K. And then we actually allow the customer to provide any additional last mile configuration with customized patches. And then once that's all together, we commit the entire sort of like new, deployable manifests into their version control system, maybe into like a GitOps repo, at which point they can either use their CI/CD process or a Flux operator or an Argo operator to actually deploy those through their exact same deployment pipelines that they use to deploy first-party software.
It's kind of blurring the line between the first party and third party, kind of vendoring and getting into one flow from developer to production, regardless of the source of the software. And so much of this stuff is blending together anyway, right? The components that we were responsible for internally versus things that come from a paid vendor versus things that come from upstream open source. That's all blurring together, and I guess that's what's driving this this product vision too, huh?
Yeah, exactly. You're going to want to consume open source. You're going to want to consume these third-party, paid vendors, and you should be able to leverage the same exact systems, workflows, and processes that you have for deploying internal applications. The idea that you have a whole GitOps workflow for internal applications, but then when you want to install Postgres, you just do like a Helm install, right? We want more repeatable process for these things, and that's what it's about for us. The way that the future of software puts everything in Kubernetes is for us to use the exact same workflows that we're already going to be doing for first-party application development to manage third-party applications.
Is there a place where users, contributors hang out? Do you have outside contributors to these projects? Is there a Slack channel or anything like that?
Yeah, there's actually a couple of, within the Kubernetes Slack, there's a Kots channel, there's a Troubleshoot channel. I think it's called App Troubleshoot. And I think there might be a Kurl channel, I can't remember. But yeah, these are all projects that, we're happy to have other contributors for. We have a couple others on Troubleshoot. I think there's a couple other, of other vendors, including Puppet and folks that have contributed to Kots. So it's, we're always excited to see more engagement here. Ultimately, this is a community-based effort, right? And we want to push these projects forward and hope to help the world move more and more towards using Kubernetes to manage all these third-party apps.
I wanted to get your take on sort of the state of running really production-grade, reliable enterprise software. I would love to just kind of hear your thoughts on the reliability space generally.
Kubernetes is the ecosystem where it matters. And so this is very different from how it was probably 3 or 4 years ago. Organizations like Facebook at that time were building tools like Tupperware, which were basically a sort of internal version of Borg. And they're doing the same thing at Uber, building Peloton, and everyone was sort of trying to make a homegrown version of Borg. And this was a pretty big wasted effort because those projects they created siloed knowledge and they required much more onboarding. And so what we love is the idea that Kubernetes becomes the canonical solution to solving reliability. And even if you have sort of a different way to different add-ons you use and different projects you use, and you like one CNI and somebody else like some other storage backend, the fact that we have kind of a common interface to integrate those with and to talk about them with, we think is really amazing. And Kubernetes to us is a great framework for putting those together and for describing how those APIs should interact with and how they should be declarative. And so, for me and for our team, it's as much about trying to move off of internally built solutions and sort of these we have these 7 bash scripts that we run in this order, and really just about embracing the Kubernetes ecosystem and helping to solve it together so that we're building the patterns and primitives together and pushing the industry forward, not all going in a siloed direction that's incompatible. So we think a compatible future is one that like allows a massive ecosystem to thrive. And it's already happened, right? Like in the Kubernetes ecosystem is so strong. I think it's where a lot of the power comes from, because because it's not really owned by any single vendor, you just get this huge amount of opportunity that every vendor can be a part of it, and they don't feel like there's someone that could at any moment like take their lunch.
Grant, thanks so much for taking the time today. I really appreciate having you here.
Yeah, it was a pleasure. Thanks for having me.
This is Kip Merker signing off.